Let's look at final exam, question number 86 in Trigonometry Demystified, second edition. Please refer to page 386. We have here a drawing, a crude drawing, but hopefully it will illustrate things, of the Earth and its latitude and longitude system. NGP, the North Geographic Pole. SGP, the South Geographic Pole. We're looking straight at it in the plane of the equator, which is 0 degrees latitude. We show plus 30 degrees or 30 degrees north latitude, plus 60 degrees or 60 degrees north latitude, minus 30 degrees or 30 degrees south latitude, minus 60 degrees or 60 degrees south latitude. And of course this is minus 90 degrees or 90 degrees south latitude, a single point on the surface. And this up here, plus 90 degrees or 90 degrees north latitude, and another single point on the surface. The longitude lines all pass through both poles and represent great circles around the Earth. You probably learned most of this in geography classes. Hopefully you have learned it all. This question asks us specifically about the line at 90 degrees east longitude. That is actually a half circle on the surface that runs from one pole to the other and lies 90 degrees east of the prime meridian. I don't show specific longitude lines here, but only this one is specific, the green one. The red latitude line is minus 30 degrees or 30 degrees south latitude. The question asks us, at what angle do these two curves on the surface of the sphere intersect locally? That is to say, if you were to stand right at that point. The answer to this question is B. Pi over 2 radians, or 90 degrees. That's pi over 2 radians, or 90 degrees, the angle at which they intersect. It's pretty easy to remember that. Every longitude line intersects every latitude line on the Earth at a right angle in the local sense, because wherever you stand on the surface of the Earth, except at the poles of course, your longitude line, as it appears to you where you're standing, runs straight north and south, and your latitude line runs straight east and west. So they're always at right angles. Each and every one of these angles of intersection, although perspective makes them look a little different, that's just the perspective of the spherical Earth. Each and every one of them in the local sense is a 90 degree or pi over 2 radian angle. You will see that. All you need to do, you can check out a globe. Look at a globe and examine closely the intersection points, and you'll see that right away. So again, the correct answer here is B, pi over 2 radians. Just as a note, in latitude and longitude systems, we rarely, if ever, will see radians used. We'll almost always see degrees used. So this question is a little bit weird in the sense that, well, the answers that I've offered are a little bit weird. But pi over 2 does in fact represent 90 degrees, so again B is the answer here.